Hey folks, this is a video to accompany section 6.2, which is about evaluating and graphing polynomial functions. So first off, we're going to define what a polynomial function is and how you can determine what it is just by looking at it. Also, what you should be able to do is to identify end behavior correctly when we're done with this video. So we'll go through what end behavior is. And then in the accompanying video, you're also going to see synthetic substitution. So that will be in this one. It's not going to be in this one here because that's going to take a little bit of time. So the first thing to know about this is the form of this, it looks like it's really weird and difficult, but it's really just functions that you've seen before. For example, things like parabolas are polynomial functions. Lines are polynomial functions. And we can have higher and higher degrees. We don't have to stop at just a degree or an exponent there of 2. They can go to larger and larger numbers. A key concept, though, is that all of your exponents for your variables are positive whole numbers. So we can't have stuff like x to the 1/3 or x to the -4 for terms. We also can't have things like 4 to the x. That would make our function not a polynomial, or the absolute value x. These are all bad. Not really bad, they just make it so it's not a polynomial, which is fine, but that's just not what we're dealing with at this point. We want to look just at polynomials for this chapter. Okay, so the first important concept that we come to with polynomial identification is something called the degree. So the degree of a function, which we call n in this case, is going to be the largest exponent for a variable. Largest exponent for a variable. And we'll see some examples, and we'll go through exactly what this looks like here. But just keep in mind, it's going to be the largest exponent for a variable. We're also, another important topic here is the leading coefficient. So in the term, this one here, that has your degree, you're going to take that coefficient, and that is your leading coefficient. And and third on our list here is that whole thing is called the leading term. So if you notice, the three things that we've talked about here really deal with just this one term here, which is usually at the beginning. Usually we have our terms in descending order, so it's really easy and nice to say, okay, what's the degree, what's the leading coefficient, what's that leading term? Makes things nice. And then usually on the far end, on the far right, is going to be our constant. Again, we don't have to have it lined up like this, but we'd all be doing ourselves a favor if we lined it up in the same way here. Okay, so let's move on to some examples here. We're going to determine whether or not a function is a polynomial. If it is, we'll state the leading coefficient, its degree, we'll state the constant. So let's take a look at this first one here and make a determination. So when I look at this, all of these terms have, if they have a variable, the exponent is a positive whole number. So that's always a good thing. I don't have like the absolute value of x. I don't have anything like 4 to the x. Like I said before, that's right out. We don't want anything like that. So this is indeed a polynomial. And now what I'm going to do is I'm actually going to look for the term of these 4 here. Which of these has the largest exponent for a variable? Well, it's this one right here. Again, usually look at that first term. It's usually where it's located. So there's a few things I'm going to grab from this. I'm going to grab the largest exponent. That's my degree. So my degree is going to be 6 in this case. I'm also going to grab the coefficient for that term. So my leading coefficient, in this case, is 7. Excuse me. And lastly, I'm going to grab the constant. Well, the constant is going to be this number without the variable. And in this case, my constant is -10. Okay, on to the next one. So take a look at this yourself and determine if this is going to be a polynomial or not. You can even pause it at this point. Okay, so the first term is okay. We have a whole number exponent for our variable, but the second term is exactly one of the things I was just mentioning before. We have 5 to the x. That piece would be an exponential piece, which makes this not a polynomial. End of story. Let's move on. Okay, let's see, h of x. Again, determine if this is a polynomial or not, and determine if it is, determine the leading coefficient, degree, and constant. So it is a polynomial. All our terms, all our variables have a whole number, exponents. The one we're going to key in on is this term here that I was almost allowed to circle. Okay, this term here that has our degree of 9 right there. We have our leading coefficient of -2. Gives us 2 of the 3 things that we're looking for. And our constant is right here at -10. So again, our degree is 9, our leading coefficient is -2, and our constant is -10. So one more here. This one looks a little strange, so we'll take a little more time on this one here. Well, as we look at this term by term, this first term here, that's x to the 1, that's not a problem. So it's a polynomial so far. That coefficient is -0.5. Well, we can have fractions for coefficients. That's not an issue. So that term is really not giving us a problem. The second term here, again, we have whole number exponent for our variable. Our coefficient can be anything. I guess it has to be real. Pi is a real number. There's nothing wrong with that. So the second term is not giving us a problem either. It's still a polynomial. Lastly, out here, this would be our constant. There's nothing that says we can't have a radical, an irrational number for a constant. So it looks like that we have a polynomial here. So what I'm going to do here is I'm just going to circle it so you see what I'm getting at here. There's my term with my highest exponent, so that's my leading term. So my degree in this case is going to be 2. The leading coefficient is the coefficient in that term. So strangely enough, this leading coefficient is pi. And then lastly, we have the constant, which is going to be, pardon me, let me get this out of the way. There's my constant right there, right? At -√2.